Okay, so we did the first four last time. Whoa. So this guy, so what's going to save you from yourself is to just always try GCF first, because sometimes it's the only thing you can do. And sometimes it makes the problem easier to do. So what's the GCF for this guy? 4. What's left? Now what is it? This is a sum of squares. I really want this to make complete sense. The reason a difference of squares works is the minus allows them to be opposite sides. And then the middle terms would cancel because they're opposite sides. So a sum of squares cannot work for that same reason. They can't be opposite sides. They have to be the same side, so the middle term would never cancel. It could never get there. So you can't factor a sum of squares. Not using real numbers anyway. We'll probably come back to this when we learn non-real numbers. That sounds freaky. Okay, so that was it. That's all you could do with that. Just that GCF. Sum of squares, you cannot factor sum of squares. This dude, what is it that tells me what to do here? The fact that there's a what, where? Yeah, this 20 is not 1. That sucks. And can I take a 20 out? I can't take shit out. So what does that tell me to do? Yeah, take that 20 into account. 20 times 3 is 60. I need factors of 60 that add to be negative 32. Negative 30 and negative 2. What happened? Negative 30 and negative 2? Yes.
Oh,
Yeah. That's all right. We got that class happening in here too. I love it. There's like somebody new in that classroom every day, and they're always loud. So now I rewrite this. 20x squared. I can rewrite this as minus 30x minus 2x, and then the plus 3 is at the end. So on one level, this is really dumb. It's like saying, I'm going to take 7 and make it 5 plus 2. It's like, ooh, good job. Right? But what we've done on another level, this is remarkably smart. I had a 3-term, crazy-ass, hard thing to do, and I made it into a 4-term, automatically easy. Because what do I do when I have 4 terms? Group. This whole step makes they're the numbers that make the grouping work. Because how many ways can I rewrite negative 32? Isn't that negative 28 and negative 4?
Yep.
Isn't that negative 38 plus 6? Holy shit, there's an infinite number of ways to rewrite it. I don't know if I'm freaking you out or if you know what I'm talking about. This is the only way to rewrite the middle so the grouping works. That's the nifty idea, if you let it be. So how does this work? I like this problem because it's a little bit freaky. If you wrote it like this, what comes out of these two? 10. X, I like it. And what's left? 2x minus 3. Now look here. Currently this is negative 2x plus 3. And on one level you can't take anything out, but I will say this to you. You can always take something out. You can always take a 1 out, which feels like you didn't do anything, but it's putting it in the format that shows you the answer. Here I don't want to take just a 1 out, though. I want to take a negative 1 out so I can change the sign to what it's supposed to be. If I take a negative 1 out, this becomes positive 2x minus 3. Changes the signs. And why is that good? Because then I can finish it up. So what comes out? 2x minus 3. What's left? 10x minus 1. Yeah. Freaky shit.
I got the same answer, but instead of the 10x, I took the 2x out and put 2x.
Oh, I'm with you. All right, let me do this another way. You ready? So here's this way. This is the way I saw most of you guys doing it. Right here on this step, I've got to use negative 30 and negative 2, but why do I put the negative 30 first? I don't have to. I could have written it like this. And aren't I still using negative 30 and negative 2?
Yeah.
And maybe a few of you guys did this. What comes out of these two now?
10.
2x. 10x minus 1. What comes out of these two? Minus 3. So that becomes positive 10x, and that becomes minus 1. See that? So look at this. This is kind of cool. Only I would call this kind of cool in here, I know. See, since I chose to put the 31st, look how my 2x minus 3 is on the inside. Yours is on the outside. My 10x minus 1 is on the outside. Yours is on the inside. Yep. But isn't the last step going to agree? You're going to take that and that. As long as they both come from somewhere, that's the right answer. Oh my God, Jeff. I'm tired. Had a rough night last night, but that's all right. Oh yeah, well, no. I tried Red Bull. It's no good, man. Good Lord. Okay. Is everybody decent with that one? So that when you get the two numbers that work, it does not matter which way you put them. That's why if I have a choice, I try to make this positive. On this problem, I was screwed. They're both negative like shit. Doesn't matter which way you put them. Okay. Oh, I didn't leave myself room for this other dude. Sure. What do I do first here? Does anything come out of all three? Damn. You always hope that 8 comes out, but nothing comes out. So you have to do 8 times negative 6. You get negative 48. Yeah, negative 16. All right, Jeff, calm down. Negative 16 and 3. Eventually you get there, right? And so you rewrite this as 8x squared. Rewrite the negative 13. What would I put first? I would put it just like this. I'm going to make that middle term positive. Maybe you guys have done enough of these. If that's a minus, that's where you can make a stupid negative mistake. Right? What comes out of these two? 8x. X minus 2. Comes out of these two. 3. X minus 2. So then you get x minus 2. 8x plus 3. Woohoo!
I got a question first.
Yes, sir.
So, I mean, when I see 8x squared minus 16x plus 3x, wouldn't you just put that together and make it, you add the 3x and the negative 16x, you won't combine them, huh? You keep them 4.
So the problem started with them combined.
Yeah.
And why does the problem suck? First number's not a 1, and it's 3 terms. Oh, shit.
That's right.
So if I break the middle term up,
Got it.
then I make 4 terms, and that's an easy procedure. When it's 4 terms or more, you do grouping, and that's relatively easy compared to cubes and all the other shit we've learned, right? Maybe. Yep. So I totally agree with you, but that's why I'm allowed to do this. Math says 7 plus 5 is 12, and then it also says 12 is 7 plus 5. So if one way is better than the other way, I can write them either way. I like it. Gotta get some WD-40. All right. Ooh. That's all I need. WD-40 and duct tape. All right. Now, what people do on number 1, and I'm not speaking directly, even though I notice a lot of people do, people multiply this thing out, but that's crazy. Because what do you do on number 2? Not at first. What's wrong with number 2? I got to get it equal to, that's the magic number. If I have 2 numbers multiplied to be 0, that's the only time I know something for sure. If I had 2 numbers that multiply to be 8, does anything have to be true about either one of those numbers? No. Do they both have to be negative or positive? No. Does one of them have to be 8? No. Right? If I know 2 numbers multiply to be 0, one of those 2 numbers has to be 0. I mean, that's when I know everything. So what is it that really tells me to get this equal to 0 is that stupid x squared. Right? What would I normally do if it wasn't there? I'd just divide by negative 10. All my x's are together. Divide by the coefficient. You're done. Can I get all my x's together now with that stupid thing there? Or are these like terms? Oh shit, we need a different process then because that process goes to shit. Right? So that's what tells you when there's a power on your x that's not 1, squared, cubed, whatever, you get it equal to 0. And yes, I am starting with this one. So you get x squared minus 10x minus 24 equals 0. And this one's a little evil. I like this one. You're going to notice a lot of problems where 2 pairs of numbers work. So 4 and 6 seem like they're going to work. But why don't 4 and 6 work? Some of you guys are like, That's what I used.
Because one has to be negative.
Because what's 4 times, if to make negative 10, they both have to be negative. If they're both negative, do they multiply by negative 24? No. So let go of 4 and 6. What's the one that works?
Negative 12 and 2.
Negative 12 and 2. They multiply by negative, and they add to be negative 10. I like it. So this will be x minus 12, x plus 2, or vice versa. Did you say vice versa? Yeah. And then, what are my 2 answers? Can anybody see them? Yeah, and just to make sure everybody really understands, this is a number, isn't it? If x is 13, this is the number 1. And this is a number. And they're multiplying to be 0. So either this number is 0 or that number is 0. So either x is 12. So you can see the shortcut. What makes it 0? 12. What makes it 0? Negative 2. But if you don't see that, you can always set each one equal to 0 separately. So look what this process does. It takes this disgusting 3-term like squared craziness, and it breaks it up into 2 easy equations. That's the trade-off. There's more equations, but they're each easy as shit. So I'm like, all right, that's a good trade-off. Maybe. So what do I do actually on the first problem? Do you notice how the first problem, there's no real work to do. Somebody already factored it for me. So don't multiply this shit out. X is either, so x minus 2 is 0, or 3x minus 4 is 0. Somebody already factored it for me. I did. You're welcome. So you get x equals 2, or add the 4 divided by 3, 4/3. So when you have something times something is 0, you can immediately set each of those things equal to 0, because one of them has to be 0. That's the only way the equation works. That's why those values you get for x make the equation work. Now I put number 3 up here just to remind you guys why we have to do this and when we don't have to do it. What eventually happens in number 3? So when you distribute, what happens to my x squared terms? So then I get my normal everyday equation. I move my x's to one side, and I move my numbers to the number. I move my number to the other side. Swedish chef is going to teach you. Do you guys see what I'm saying? So what is it over here that told me to make it equal to 0? What is it again? The x squared. What's the first thing that died here? X squared's died. All I got is x. Oh, now I'm back in chapter 2. Just get my x's on one side, my numbers on the other side, and then of course divide by the thing I don't want on my x. There you go. X is 8/7. Woo-doo! So don't think, every time we learn something new, it doesn't mean everything that we knew before is different. That is impossible. Everything we knew before is still there. We learn something new when there's something that happens that changes the process. But over here, the thing that changes the process died. So I can go back to the old process. X is on one side, numbers on the other. Numbers, huh?
So 8/7 will factor in to make a 0?
Yeah, believe it or not, if you put 8/7 in for x everywhere, it makes it a true equation.
All right.
If you want to do that, I don't feel like doing that. You can do it just to make sure. I feel pretty good about what we did.
Yeah.
I don't feel like doing it. Okay. I could do it. I don't want to. Okay. So, let's do this. Section 6.6 is nothing new. Section 6.6, I know, dude, yeah. Section 6.6 is just they put all the forms of factoring all together. So what I gave you a minute ago, everybody should have gotten, they kind of have all these little steps here, blah, blah, blah. I gave you the sheet, which is a little overwhelming. I understand. That is really overwhelming. So what I wanted to do was, at the very top is my quick reference. first you'll do GCF no matter what. You just always look for GCF first no matter what. Because sometimes it's the only damn thing you can do. You can go insane if you don't think about it. And then if there's 4 or more terms, a group, 3 terms, trial and error, or surefire, massive product, AC, whatever the hell they want to call it. The X, if you do that. 2 terms, it can be difference of squares or some difference of cubes. And then what I did down here is I really got like a detailed explanation example about each one. So the top is just a quick reference, and then each of these is kind of like a example of how each one works, right? So I'm hoping maybe this is helpful. If I'm doing my homework and I'm you and I'm doing my factoring homework, I'm going to have this sucker sit next to me. No, you can't have it on a test. I'm hoping as you do it, it gets to stick in your brain. It's my hope. So in a test, you will not be allowed to have little note card about factoring, because the whole point is you learned factoring. So 6.6 I'm not really going to say much about. It's just all the factoring forms all at once. And I've already done several handouts where I did that to you, just to get you ready for it. So like a number 2, what would you do first? This is page 121, which is 11 squared. What would you do on this one? GCF. Yeah, what comes out of there? Careful. And then what's this?
X minus y plus 2 minus 2.
Yeah, so this is a difference of squares. So just because you did something doesn't mean you're done. You look at what you got left and see if it goes further. So sure enough, this is y plus 2y minus 2. A nice little thank God problem, what I call it. A little difference of squares problem. So GCF very often is just the first step. And then you look at what you got left and you figure out what to do from there. On a problem like number 1, I always get somebody that does, I'm sure you guys can all see the GCF on that, right? And then I get somebody that tries to do this. Oh my God, no. So if I take a 2x out, I want to first tell myself what the shit there is. So what do I get when I take a 2x out?
X squared.
X squared minus 4x plus 1. I like it. Now I can say, okay, will this factor? Well, will that factor? Will it factor? Any factors of 1 that add to be negative 4. That's Harry Potter level shit. I mean, that's not going to happen. There's only factors of 1 are 1 and 1. Can you make negative 4 out of that? Nope. So that, no, it's not prime. You're just dumb. That piece is prime, but the problem wasn't prime. We took a 2x out. So see how very often GCF is the first step. Not always, but you always look for it to see what it's going to do for you. Let's do a cubes. That's our favorite. Yeah. Number 6. See if you guys remember how to do that. You'll start to see these same numbers. 8, 27, 64, 125. Those are cubes. So it's pretty much a giveaway. But that's a cube. Plus the cube is a giveaway too. So remember how I break this up here first. To be. Like a little Hamlet with Tourette's. To be. 27, 3, 3, 3. I want to see that Tourette's Hamlet. I want to see it. And what do I put down? I put little dude, big dude. What goes? Well, the minus sign is there. So there's so many different ways to teach this. And the way I teach it is, whatever that sign is, the little dude has that same sign.
So you don't.
So I look at the 27 by itself, instead of it being negative 27. So what goes here? Yeah, 1, 2b minus 3. So what has to go here? 4b squared. What goes at the end? 9. And what sign is the middle term going to have? Positive. That's negative, so that's got to be positive. What's the middle dude's job? Kill the shit I don't want. That's what his job is. Right? The job of that middle dude is to clean away all the stuff I don't want in the backseat of my car. And what goes here? Yeah, go ahead, say it. 6b. It's this times this, whatever the hell they are. It's kind of awesome. At the same time, you're like, no, it isn't, Jeff. Man, that's disgusting. But 1 of each, 2 of each product in the middle. Yeah. Oh, yeah. So this is the same sign. See how it's negative? So that's negative. Same sign. This is opposite sign, so this can kill stuff. And the last one's always positive, so it doesn't change that. Soap. Which, again, I kind of like because it goes along with my whole cleaner dude. Okay? So very often what I'll tell people is, like at least 10 minutes before a test, don't look at anything. Because you end up just freaking yourself out. But I might do, if I were you, a few cubes right before a test, because that's something where it just has to be in your head. You know what I mean? So that's one thing I might say. Yeah, do that right before a test. Look at the cubes. Make sure you got it down. Okay. So look what we're going to do. Yeah, dude. Go to page 126. If I throw something to somebody, or like throw something over there, what shape does it take? Well, be more specific, related to, parabolic, right? Parabola. So, rainbow. I like it. So when somebody throws a baseball to somebody else, the trajectory it takes is very parabolic. Now, we're not going to take into account all the other variables, the wind and the temperature density of the air, and oh my God, it's basically a freaking parabola. This equation ends up being a downward parabola, so it will actually look, if I graphed it, it would look like a baseball flying through the flippin' air. The arc it makes, right? And just to get even a little more specific, just so you know this isn't shit they just made up, that 16, that negative 16, is related to the acceleration due to the gravity of the Earth. It's really neat. The gravity of the Earth accelerates everything 32 feet per second squared. So every second, something goes 32 feet per second faster as it falls towards the Earth. Do you have to understand anything of what I just said to do this? No. But I'd just like to point out to you that, yes, that equation is actually completely correct. It ignores, like I said, the wind and all that stuff, but it's pretty accurate. You can make really good estimates. So, what does H represent? Height of the baseball. And what does T represent?
Second.
Time in seconds. So when they say, how high is it after 0 seconds, what are you going to do? Plug 0 in for T. So this one is just H of 0. So H of 0 is, I think somebody said it, 3. It kills all the stuff with T in it. How about how high is it after 2 seconds? What would you do? Oh my God. Okay, so I'm going to skip these. So 2 and 3, just plug a 2 in, you plug a 3 in. Ooh. Is everybody cool with that? Because that's what that function does. You feed it a time, it spits out a height. Okay. Now here's the interesting question. At what values of T, at what time, another way to say this is, at what time is the baseball 75 feet up in the air? So where do I put 75? It's not 75 seconds. It's not a time. I replace h of t with 75. I want the height to be 75. Oh my God, let me write that again. So I get 75 equals negative 16t squared plus 88t plus 3. Woohoo! There you go, Jeff. That's a 3. Pretend like that's a 3 for me. So, how would you solve this thing? Yes, good. Get it equal to 0. Don't factor it yet. I got to get it equal to 0 first, and then I factor it. Now, let me talk about something that could be very subtle. This negative sucks a lot. It's bad enough the first number is not a 1. It's also negative. That desperately sucks. So when I make it 0, I'm actually going to do something you wouldn't think of. I'm going to move things this way. Because then that becomes a positive. You don't want the first number negative. You don't. Just trust me. So I'm going to add 16t squared. I'm going to subtract 88t. And I'm going to subtract 3. So I added 16t squared. I subtracted 88t. And I subtracted 3. So I got it equal to 0 now. Now, what would you do to factor? Do you want to do 16 times 72? I don't want to. Thankfully, I don't have to. What can I do to make this a little bit better? What goes into all of these? Anybody see? Yeah, does 4 goes in, but 8 goes in. Isn't that awesome? 8 goes into all of these. 16 would be even better, but unfortunately 16 doesn't go into 88 or 72. So if I take an 8 out, now watch. All right. I could take an 8 out, but don't I have an equation? Isn't there an equation there? Can't I just divide everything by 8? I don't have to carry that stupid 8 around with me. Because I have an equation. I can divide both sides by anything except 0. So what do I get here? Careful. 2t squared.
11t 9 is 0.
Am I as loud as the teacher next door? I feel like standing next to the wall and just shouting things and man. There you take. Sorry. All right. Now, look at that. Isn't that a lot better? If you could take something out, you do it. In this case, I have an equation. I can divide it away. And I made all my numbers smaller. So instead of 16 times 72, I have 2 times 9.
So because it's set equal to 0, you're able to divide.
Totally. I wasn't able to do that before because we didn't have equations. We just had expressions. So I had to carry the number with me. There wasn't another side to get rid of it in. So 2 times 9, 18. The factors are staring you in the face. 92, but they both have to be negative. So it kind of makes sense to do them like this. 2t squared minus 2t minus 9t plus 9. Put the 2's and the 9's. Doesn't really matter. So I took the 11t and I split it up using the numbers that work. And now what can I do with this? Group it. What comes out of these two? 2t
T
minus 9.
T minus 1.
Yeah, you divided a negative out so the signs both change. The very people I see put plus 1 all the time here. 9 divided by negative 9 is negative 1. Now, so there's my 2 answers. I got t equals 1, and I get t equals to 9 halves for the add 9 divide by 2. So why does it make sense there's 2 locations? Because when I throw something in the air, it could be this high in one place, but then later it's going to be that high again. Because it goes up and then it comes back down, right? You guys with me? That's why I got 2 answers there. When is it 75 feet high? Well, the dude threw it, and it was 75 feet high there, and then it's 75 feet high again over there. There's 2 times when that happens. That makes physical sense. And this is leading to the kind of math that you program a rocket with. So it knows the trajectory you want it to go on. And you actually end up changing the numbers in the equation that makes it move, that makes it turn different ways. It's crazy. Or you got another rocket coming, you figure out its trajectory, and you program yours so that it blows up so it doesn't hit your city. Right? Okay. All right. Then we get, I just wanted to make this happen. I know it's been a while, so yes, we're back to word problems finally, thank God. Look, do that one. Do it. Draw the picture. Oh, you're so funny, Jeff. Whatever. So the new thing here is, notice it doesn't say perimeter. We've done perimeter problems before. That's when you add things together. Here I'm going to do area. What am I going to do with the length and the width then eventually? Multiply. That's when I'm going to get squared stuff. That's why I couldn't do this kind of word problem until now. So which one is going to be just a letter?
Length.
Yeah, it's 5 feet longer than it is wide. So be careful.
So the width.
Width.
W.
So, and then the length would be
5 plus W.
5 plus W or W plus 5, either way. Addition is a nice thing. You're not going to get it wrong. And now, so if I label stuff, W plus 5, W plus... What's the area, though? I don't need all those, right? Perimeter would be add them all up, but this is area. You got to pay attention. This is area. What's the area of this thing? Yeah, so the area would be length times width. And they tell me that that actually is equal to 126. There's my equation now. Now notice something. This is really evil. Do you see how this is factored? Right? Isn't this factored? But it's equal to shit. So I better multiply it out, suck the 126 over, right? Make it 0 and then factor it. It's almost like it was factored too early. So multiply that back out, and then I can subtract the 126 over. So these are the word problems that immediately use this equal to 0 idea, because they end up with these squared pieces. Area is going to have squared pieces because it's multiplication. Perimeter didn't. That's why we could do that before. So now what do you do? I type it in Google and I see if somebody else did. No, yeah, you factor it. Stupid Google. Right? Do you guys with me? So there was a W squared thing. I had to get it equal to 0. So then I can factor it, because in each piece I can set equal to 0. Now this is, I think some of you guys are looking at it and you're not looking forward to factoring this. Right, you need two numbers that do what? And add to be 5. So I would start with the add to be 5 thing. They multiply to be negative, meaning that they have to be same sign or different signs? Different signs. Which means that they actually subtract to be 5, because they're different signs. Okay. Steal my thunder. So you could do like 10 and 15. If the 10 is negative, don't you get negative 10 and 15 to add to be 5? But they multiply by 150. It's too big. So then you go down to 9 and 14. And sure enough, 9 times 14 is negative 126. Which one's negative? The smaller one, so that the middle term comes out positive. So I get W minus 9, W plus 14. Okay, now, this is really cool. Math ain't got no eyeballs. That's the weirdest sentence. Math don't even have a consciousness. So mathematically, math is going to give me two numbers at work. We know those numbers represent a what?
Square.
What numbers do I get? What makes this 0? 9. What makes the other part 0? Okay, what's wrong with one of those? Can't have a negative width. If you can, please don't invite me to your house after you've made your negative width shed in the backyard, because that's the singularity. We're all getting sucked into that thing. I don't know what the shit. So please, dear God, don't just circle this stuff and go forward. This you throw out. It's not saying that mathematically it's wrong. Numbers can be anything. But a width has to be freaking positive. Right? Is that cool? So the width is 9. What else do I need? The width is 9. 9 what? Feet. And what's the length? 14 feet. And there's your 14 times 9 is 126. Yay! Okay, maybe. So it's exactly the same idea as word problems before, except now the equations are going to involve squares. That requires factoring. Let's do one more. Who remembers, did we talk about Pythagorean Theorem? I think we did. No? Who remembers Pythagorean Theorem? A good old Greek dude, Pythagoras. Yeah, and the really cool picture. I'm almost sure I did this, but maybe I didn't. So here's A, B, and C. Man, my little triangle sucks. And watch this. If I draw a square off the edge of this, it's going to have an area of A squared, right?
Right.
That's A, B, C. If I draw a square off of this, it's going to have an area of B squared, right?
Right.
B squared, BB. And then this is going to be... Oh my God, Jeff, you shouldn't be looking there. All right, you get the idea. C squared. Oh, shit. Okay. And what's really cool is there's actually a video on YouTube that if I felt like it, I would look for it right now. But somebody built this thing so that there's water in these. And when you rotate it, all the water goes in and fills this up perfectly. So this area plus this area equals that area. Why is that the biggest area? Because it's the biggest freaking side. Right? That is why it's A squared plus B squared equals C squared. Because it's the areas of these squares that add up to be this one. Does that sound familiar at all? You guys know Pythagorean Theorem? You don't have to know Pythagoras. He stole all his, or most of his results from his followers, had them do the work. Sounds like it works today. But
Sounds like a business.
So what would it be for this? Yeah, exactly. What's the most important side in this triangle?
The hypotenuse.
Yeah, which one is the hypotenuse? The hypotenuse.
Yeah.
The one that's across from the right angle, that's the largest angle, is going to open up to be the largest side. So that's going to be C. These don't matter which one's A and B. So how's this formula going to work now? One side squared plus the other side squared equals the hypotenuse or the hypotenuse squared. That's like hypotenuse. Don't say hypotenuse when you talk to a math person, unless it's me. Do you guys? So you're going to see some problems in the homework that have this triangle like this. It's a right triangle. You can set up the Pythagorean theorem. Now you see why there's a whole bunch of squares running through this thing. Do it. Finish it up. Solve it. What are you going to do next? Please, dear God. This is not x squared plus 49, right? This ain't. We know better. Squares don't go across addition. You have to write this twice. Foil it out. Same thing with that guy. Finish that out. Ooh. Yeah. Is that over here or over there? What's over there? I felt her like do a point on that. See over there?
Yeah.
It's freaking me out. Alright. So let me catch up to you a little bit. So this would be x squared plus x squared plus 14x plus 49. Is that, so if you write this twice, did I unfreeze it? Yeah, think of it. You get x squared plus 7 is 14. Plus 7 times 7 is 49. So over here you're going to x squared plus 8x is 16x plus 64. Do you notice how one of these x squares cancels? See it? That's nice. And then what else do I want to do? What do I need to make this? What do I need to have happen?
Yeah, factor it out.
I can't factor yet. I need to get everything on one side and you get it equal to 0. So I end up with x squared minus 2x minus 15. Yeah. That's nice. How do you factor this? Yeah. So I get x equals 5, which makes physical sense. X equals negative 3 does not make physical sense. So if the question was, what are the side lengths? What would the side lengths be? 5? Yeah. 12? 13. I like it. Does anybody know the 5, 12, 13 triangle? Like there's another one, 3, 4, 5. Because 3 squared plus 4 squared equals 5 squared. So there are a few triangles where the sides are nice whole numbers, right triangles. But most right triangles, the sides will be radicals because of all the squares in the equation. But there are a few like 3, 4, 5, 5, 12, 13, 7, 24, 25, I can't remember. Okay, oh my gosh. Just to give you a little preview and then we're going to head out, I want to show you the next thing we're doing with factoring. All of chapter 7, there I am, I'm loud now. All of chapter 7 involves factoring. So if you cannot factor, don't try number 7, chapter 7 out yet. Well, look at this problem, for example, number 3. Just to make sure you guys, help me out real quick, little side note. Can you reduce 8 over 5? Can you reduce that? No, why not? Yeah, 8 doesn't have a 5 in it, right? But isn't 8 5 plus 3? Your answer should be yes, so what, Jeff? Because this is addition, this is division. What do they have to do with each other? So can you kill the a squares?
Yeah.
Shit, no. Can you kill the 5s? No. Of course you can't, guys. Is 8 divided by 5, is 8 divided by 5 equal to 3 or something? No. You're just being like that, okay. Division can't kill parts of an addition problem, right? So what am I supposed to do with this? I have to do what? Factor, which is what we actually do. Can I reduce 8 over 24? Yes, because 24 is 8 times 3. Of course, we don't often have to do it because we kind of know it in our head, and that's why this is 1/3, right? But when I have shit like this, oh crap, I better do it. How do you factor the top? I like it. How do you factor the bottom? Factors 42 that make 13. 7 and 6. And look, what cancels now? What's the same?
A plus 6.
A plus 6. That cancels. So my answer is that. A minus 6 over A plus 7. So one of the next things we're going to do is this. Is we're going to reduce these variable expression ratios. Oh, God. But the more you understand factoring, the easier these things are. The less, the less. Yes?
What's going to be on the test?
We'll know for sure at the end of next week. The next test isn't until, after next week, right? I can't remember. The 30th, I think it is.
So there's a quiz on Monday.
The day before Halloween. Yeah, Monday's the quiz that was supposed to be today. It's going to be Monday. That's, give me a second.
6.3 and 6.4.
Yeah, that sounds right. Yeah, 6.3, 6.4. So the surefire method and the squares. That's on Monday. That's that quiz on Monday.
Not the cubes?
No cubes yet on there.